Hello everyone. So today we wanted to look at a business scenario where we wanted to compare two SQL queries. One is generated by a self-service tool and the other one is the gold standard semi-reference SQL query. So idea is to that we have once we have two different SQL queries, right, we can compare it into different aspect. How well the SQL queries being generated by self-service are able to solve the business problem what SMEs are using. So here basically we have used claim data where we have a claim level data, right? Then for each claim we have a line level data, right? And then for each line we have a event level data. So basically this database we are using. So currently just showing the apple to apple comparison where we have exactly same queries, and when we run it we are getting a 100% match. So under the hood we have got three tools. One is the metric identification, which has got a 40% weightage, followed by the query formation, which has a 40% weightage, and the result one, which has a 20% weightage. The metric identification basically looks into what all metrics are being calculated, derived in the query, and how well it is matching to the SME query. So currently, whatever the matrices we had, right, they are well captured, and so it is giving a 100% weightage. The query formation is more of a degradation and fragmentation of the queries where we are looking at the specific table, join, filter, condition, group by aggregate, and select clause each of equal weightage, and then we are doing a Jacob similarity approach through which we are comparing the result. This tool again has a 40% weightage, and the finally we have a 20% weightage where we just comparing the result, how well it is equal. So when we do some different query comparison where I have just made a change, right, where instead of count of star we have a specific column, and just from one table we have a table plus a line level join as well. So in this case you see that it is failing because it is not meeting the threshold of 70%. And if you look at the result, it is giving the highest matching rate of 90% because structurally the table outcome seems same, but the value wise the values are not coming same, and actually the query is being executed at DB level. At metric identification, total metrics in the SME were 5, but only 2 were correctly identified. And if we see that wrongly identified ones are the count of a star, and the other ones where we are reasoning logic is not coming correctly, or the arithmetic logic is not coming correctly, and this is mainly happening because of that inner join. We have a query formation where the table join is failing miserably, right? And the other ones are impacted because of this particular thing. So let's see how at code level basically things are working up. So let me show the readme first. So we have a UI which we have seen. Under the hood we have got three tools, and then we have a prompt template and the LLM provider class. So each tool works independently in a sequential way. Each have a separate prompts which are pretty much if you look at the prompts now. So the first prompt is something where uh, we have providing the schema context, right, to provide the metadata of the table. Then we are giving it the task along with the schema context, what it needs to do, how the scoring needs to be done while getting the different matrices. Then we have the business question generated and the query, and we are having a specific output how we are looking the outcome to be. Then we have the second tool where we are providing the context of the output of the tool one along with the Jacob similarity, the mathematical framework through which we want to evaluate this with different component weighted components, right? And this subtask how that needs to be done, that is being called out to the LLM. Again we have a specific output format which needs to be followed. Similarly in the tool 3 we are providing the output of tool 1, tool 2 along with the how the result agreement needs to be done. based on the, and we are expecting few methods like the top key overlap, correlation, Pearson correlation, and the value level agreement, which is something we wanted to classify the model to run on top of this. Again, we have a structured output, and the formatting and everything is being done here through different helper class. And in the tools, basically we are calling, along with this helper class, we are formatting the output, which is again, uh, used to extract the output into a specific, whatever the specific JSON we are getting, we are extracting it, formatting it in a specific way. For example, if there are some commenting done in the SQL query, we don't want it to go, so those things are being done, maintaining a specific conversation history, right, metric evaluation and everything. And at the end, how we are for each tool, the metric evaluation, at the end, how we are collating the result in the final query into the memory, and the final score, how well we are calculating and showing on the UI. Then we have the schema, which is a pydantic one, where we are defining the tool definitions, right, how we are caching the system block, right, how the response format needs to be adhere with the base model classifications of the chat request, chat response, along with the tool results as well, right. So how the grain analysis needs to be done, need to adhere, and all those things we are kind of, uh, calling it out here properly. Then in the provider is nothing but where we are using the uh, specific Databricks provider, where again we have some flattening logic, and we are defining the base provider here as well. We are using the database cloud provider for net 4.6, and that's what we are calling it out using the environmental file. We are reading the configuration, and then we are, caching and auto parsing the JSON, and doing all the nitty gritties around that. So this is what I mean. The important thing which we I wanted to show is more kind of a prompt validator, where I had defined few of the criteria based on which my prompt needs to get evaluated. So if I look at a result here, so I send a prompt where all the system prompt needs to be the prompt validator, and I had given all the tool prompts as a user prompt and asked to validate it. So if I see the result, all the important ones I am getting true, right, and the evidence is also being called it out as in the output. And it's not that in the initial shot we had got this view. I wanted to show one of the old prompts, right, which is being evaluated to the prompt validator, where some of the tool separation logic and fallback logics were not handled properly along with the conversation loop, and it was calling it out as false. And with multiple iteration, we kind of narrowed it down to the right prompt, and that's how we should practice, so that we are able to evaluate our prompt in an effective way, how well it is, managing the hallucination in case we are getting it. We don't want to get any false values to be considered, which are not within the business specific domain logic. So those things, how will we are validating here, is kind of demonstrated. Thank you.